All right, welcome back to Introduction to Computer Networks. This is Polly again, and we are in week 15. Hooray! This is the last week of lecture, and next week is the final exam, and then we are off for the summer. Okay, and today is the episode 27. Just like what we do always on the Tuesday session, let's check out the assignments due. Okay, so this, despite being the last week, we still have quite a bit of assignments you need to turn in. And that's, I think, 1, 2, 3, 4, 5, 6 quizzes. Okay. Good thing is that we don't have PA anymore. PA9 officially ended, and all of you did well. And so what remain as are just 6 quizzes. 2 of these quizzes, 49 and 54, are straightforward, calculative. Okay, so this should be straightforward for you guys. But there are 4 quizzes from quiz 50, 51, 52 to 53. There are 4 quizzes in a series. They could be trivial at the beginning, but towards the end gets complicated. And these series of quizzes are very important, just like the series of quizzes to make a point about distance vector routing. So this time, 50 to 53 are together to make a point about BGP. BGP is the inter-AES, the only one and only inter-AES routing protocol, which is very important, essentially determining where the data goes on the internet every day, every second. Okay, so these quizzes together will prove a point that BGP routing needs to be policy-based. Okay, hey guys, if you recall, we spent a lot of time the past couple weeks, right, introducing 2 routing principles, distance vector and link state. And hey, the goals that we are trying to achieve there are all trying to calculate the shortest path. But you will see on the internet with 2 levels of hierarchies of routing, that is just not going to be possible, and it doesn't make sense, right? You try to optimize to get shortest path lower level, and then try to get the shortest path higher level. In fact, the shortest path at the higher level doesn't really make sense because an AS can be huge. So to the inter-AS routing at the higher level, that could be 1 hop, 1 node, but that can be a super slow node. All right? So again, BGP routing is no longer straightforward shortest path. It's shorter path preferred, but in case there's policy wins, okay, type of routing. Good, so I'm trying to give the complexity of the lectures this week to you guys ahead of time. And guys, next week is the final week, okay? And we have 2 lectures per week. The Tuesday session next week will be canceled, okay? So it's not going to be lectured next Tuesday. And that is time reserved for you guys to study. And Polly is going to be online on Discord and Google Meet. There's a Google Meet session. We don't use it very often, but in case you have questions, post it on Google Meet, post it on Discord, or just call in from Google Meet, and we can discuss. All right? And that's usually the most effective session because it's just the day before the exam. All right? All right, and good afternoon to all of you, including Ricky, William, and Ivan. Okay, good to see you guys popping up. Even this is already the last week. I know towards the end of the semester, every class gets tough. Yeah, and you are pretty much stressed out already. Guys, just hang there. I know for sure that for this course, exam 3 relative to exam 2 and 1 will not be super challenging. All right. Make sure that you are familiar with the PAs. Make sure that you exercise, and make sure you study the O exams, at least one of them, so you see the style of the exam and what type of questions are coming ahead. Good? Now you guys are prepared for the end of the week, the assignments, and next week. Let's now try to get this done, okay? We need to talk about BGP. Okay, and here's a quick recap. Last couple of weeks, we have introduced two routing principles, right? Link state and distance vector. Link state, hey, more controllable, more predictable, more robust, but distance vector, more scalable. And you see that scalability and robustness, these are very important features that one would really like in a routing protocol. But unfortunately, one will need to pick and choose one of these for different scenarios. And towards the end of last week, right, we started talking about internet protocols, internet routing protocols. And we introduced one protocol called OSPF that is in the link state flavor. In fact, it's exactly link state routing, all right? BGP. BGP is the inter-AS routing. And you can imagine, right, there are so many ASs around on the internet, and the number of these ASs is probably still increasing. So for inter-AS routing, one will need to pick a routing protocol, routing principle that's scalable. You are right, BGP is very much like the distance vector, all right? With that said, now let's recall distance vector. Okay, so you get a little bit of context before getting into BGP. Distance vector principle works this way. It's an endless loop of 3 steps, if you recall. First step, collect distance vectors from the neighboring routers. With those information, right, we apply the Bellman-4 computation, right? We went through quite a bit of quizzes to exercise doing the Bellman-4. And after you come up with your own distance vector, and if the distance vector is newer and better, the router propagates the distance vector further. So the neighboring routers can derive their better, newer routes as well. Okay, so that is distance vector. You know what? BGP is very much like that. It's also an endless loop. Each BGP router runs this also an endless loop, but 4 steps. First step, very similar to distance vectors first step, collecting distance vectors. But in BGP, we collect this thing a little bit more general called reachability information. To be precise, it's not exactly distance vector. Distance vector is what? For a router, what is the shortest distance to a particular destination, right? And you probably also know what is the next router to forward the data to, so that we can take on the shortest path to the destination. But in BGP, that information, that distance vector is really now a path vector. Okay, it's not just the next hop. It contains actually all the hops to the particular destination. And there's many destinations. If it's internet having n ASs, that will be n entries, n AS paths. Okay, and those is the information that a BGP router will collect in step 1. In step 2, this is where BGP and distance vector differ as well. First is it's no longer distance vector, it's path vector. Second is this. You see, BGP runs inter-AS, but when data is generated by a user, it's generated within an AS, right? And these data, a lot of times needs to go outside of the internal domain to somewhere else. So these internal routers will need to know where to send the data to, so that they would know which is the AS path, the next hop in the AS path to forward to the destination. So second step is for the inter-AS routers within an AS to pass these AS path information internally. So these are collecting information from other ASs, that is the external BGP sessions. And the passing of the AS paths internally, those are the internal BGP sessions. Okay, so internal BGP sessions compose together the first and the second steps of BGP in its endless loop. Third step, then is the route computation. But that's the third difference now. Distance vector does the Bellman 4 computation. It is indeed a computation, but in BGP, it's a decision, really. Okay, partly shortest path, partly policy. And you will see that in BGP, this AS path information is not just AS path, there's something extra for the routers to decide what is eventually the route to select. Okay, that's step 3. And then step 4, straightforward, just like the distance vector, to pass the AS path information further. And by the way, these AS paths are later on in the videos called the reachability information, because it starts off from the destinations. The destinations, as they are put alive on the internet, they will announce their own existence. And that existence information gets propagated to the neighboring ASs. And that's how the AS paths are formed eventually, reaching all the ASs on the internet. All right? So that is a nutshell lecture of BGP routing, okay, to start today off. I'm sorry that it's a little bit long, but that should be giving you a clear sense of how BGP is like, so that it's easier to consume the videos coming ahead. All right? So first video, straightforward. It's the overview of BGP. You will hear Polly talking about BGP is an endless loop of 4 steps, and we are sending not just distance vector information, we are sending path vectors. Okay, so this video, 5 minutes. Now the second big category, the inter-AS routing. There's in fact just one protocol defining the category, the BGP. Now this is also the routing protocol that runs on all these gateway routers, okay, that are higher in the internet routing hierarchy. OSPF, DRIP, eDRIP, those are the intra-AS routing. So those runs on the regular routers, okay, within an AS. Now, network admin gets to choose one intra-AS routing protocol versus another, okay, as long as all the routers within the AS runs the same routing protocol. Similarly, at the higher level, these gateway routers, okay, in order to find a way to reach each other, they need to run the same routing protocol as well. You see, there's no need of having an alternative, okay, inter-AS routing protocol. Therefore, BGP here is the only inter-AS routing. Very critical. It plays the role of enabling all these packets being exchanged, okay, in the core of the internet. We'll talk more about BGP, but let me share just a little bit ahead of time. Yeah, BGP here is based on the distance vector routing. To be exact, okay, it's based on the path vector routing. So in distance vector routing, the router tracks for each destination what is the shortest distance and what is the next hop, okay, along the shortest path to the destination. In path vector, okay, so this one running at the inter-AS level, the source AS will track for each destination AS what is the entire AS level path, inter-AS level path. So that inter-AS level path will contain all the intermediate ASs, okay, along the way from the source AS to the destination AS. So what's nice about keeping track of the entire AS path is this. The source AS knows by default what is the next hop AS. And by counting the number of ASs along the way, you get a rough sense of the path cost as well. But the downside of tracking the entire path is that the memory requirement is higher. But this is okay, right, at the inter-AS level, because we try to aggregate destination IP addresses, right, into prefixes. Okay? And if we do that as much as we can, we are not actually storing a big vector containing one entry per IP addresses. Okay? Potentially, we just have, you know, a low number of these prefixes, okay, to span the entire IP address space. So path vector is exactly what BGP, this one and only inter-AS routing, is based on. First line, BGP stands for Border Gateway Protocol. And once again, it is the one and only inter-AS routing protocol that's holding the internet backbone together. To be more precise, it allows each AS the following. First, it allows the gateway router there for the AS to receive subnet reachability information from the neighboring ASs. This is very similar to distance vector. A router receives distance vector, okay, from the neighboring routers. So the gateway routers in the AS receive path vector from the neighboring AS's gateway routers. So by subnet reachability information, we meant the path for each destination subnet for each destination AS. Okay? And there are many of these destination ASs, therefore, we receive the path vector, okay, from the gateway routers of the neighboring ASs. Second step, the gateway router receiving such a path vector will then propagate it to all the internal routers, okay, including those routers are gateway routers to other neighboring ASs. As a result, okay, each of these routers within the AS can calculate what is the best path for a particular destination AS. The calculation can be based on what's provided in the path vector. For example, the path length, right? Or based on the policy of the organization owning the AS. Now, this is more and more likely the case how a router determines what is the best route. Okay? The policy can well be profit-driven, business-driven, security-driven, and things like that. And in the end, when a good AS path is selected for a destination AS, the border router there, then can append, the AS's AS number to the AS path derived, and then further propagate this to the neighboring ASs. So that completes the cycle of receiving path vector, doing the calculation, and then pass the path vector on to the rest of the internet. And of course, at the beginning, the AS gateway router will announce itself, right? So each AS is potentially a destination. It will announce itself's existence to the rest of the internet. All right, so 4 steps, and it's an endless loop. Okay. Now, in the second video, Polly is going to talk a little bit more about the reachability information, aka the AS path. And a little bit also more about the eBGP sessions to collect path vectors from the neighboring ASs, and the iBGP to propagate these AS path vectors internally. And then you will see an example, Polly showing a particular destination just new, adding to the internet destination X, and how X announces its existence. And that existence advertisements gets propagated to the neighboring ASs connected to X. And the neighboring ASs will actually prepend their ASs to this advertisements. And gradually, all ASs receiving these advertisements will prepend itself, then composing the AS path. Okay. So second video, about 4 minutes. One last point to make is just this: the reachability information, aka the path vector. When they travel across the border, go from one AS to another AS, this is actually part of the exterior BGP protocol. So in exterior BGP protocol, we established the exterior BGP connections to allow path vectors travel across borders from one AS to another. Now, for path vector, that is supposed to be sent internally to all the internal routers, then belongs to the iBGP protocol, and they are sent through the interior BGP connections. And these are actually illustrated using this picture here. Okay, so if we focus on AS2, we do have 2 gateway routers, 2A and 2C. So you see these gateway routers connecting to other ASs. There are exterior BGP connections to outside, exterior BGP connections to outside. So eBGP, in red color. But in addition to that, 2N and 2C both need to send path vectors internally. Okay, so you see they went through the iBGP connections. All right, so iBGP connections in blue. So once again, these are gateway routers, and the gateway routers you see having both the red connections and the blue connections. They run both the eBGP part of the protocol as well as the iBGP part of the big BGP protocol. Those BGP connections are often referred to as the BGP sessions. So these routers will exchange messages over semi-permanent connections. The reason that they're called session is probably because it's semi-permanent, so it's on all the time, and occasionally you take it down and then restart it. Okay, so semi-permanent TCP connections. Now, TCP, BGP is a routing protocol, right? These messages we send should be at the layer 3, but TCP is actually a layer 4 protocol. Okay, how do you like this? On the other hand, TCP allows reliable data transfer. So would you prefer the pass factor? So these messages that we're exchanging between the BGP routers, the pass factor is being sent reliably or not? Yeah, to push it a bit further, what about using TLS, okay, the secure version of TCP? And if we use TLS, these BGP messages, these pass factors, would look more like an application level message. So you think about it, you debate within yourself. Now, the messages we're exchanging between the BGP routers over the BGP sessions are these. Yeah, the pass to all sorts of destination networks, the pass to all sorts of destination ASs. In fact, yeah, altogether, we just call it the pass factor. Okay. So BGP, again, a pass factor protocol. And let me give you an example here. So let's say in AS3, okay, there is a prefix X, okay, and this is the destination for packets coming from maybe AS1 or AS2. So AS3 that learns about this destination will need to announce, okay, advertise it to outside of AS3. So 3A here, okay, will need to announce, okay, its existence and pending its own AS number, so AS3 here. So this will be the AS pass, okay, being advertised. This will be the AS pass being sent in the BGP message to the other end of the exterior BGP connection, to the other end of the BGP session. So 2C here, okay, will receive the AS pass, AS3, X. So AS3's gateway router 3A will advertise the pass to AS2's gateway router 2C. So when AS3 does this, it's also saying that AS3 promises AS2 to relay packet, okay, on behalf of AS2 so that it can reach destination X. All right, so reachability information, aka the AS pass, starts off from each of the ASs announcing its existence. And as this existence are sent over the BGP advertisements, it accumulates all the intermediate ASs and forms the AS pass. So BGP advertisements are essentially how you send the AS pass around, arrive the AS pass. Good. And you know what, guys? We have a pop-up poll today, okay? And number 1 is coming right now. The question is here. If you pay attention to the video, you hear Polly asking already, right? Do you like BGP sending these reachability information or these BGP advertisements through TCP? Okay. Yes or no? And if you have a reason, let us know. Okay. Good. So you guys working on that. Let's move on to the next video. I know some of you might need to think through. All right. So next is this. Now you know the reachability information is essentially the pass factor. And you heard Polly saying that, hey, the route computation is not exactly computation. It's a decision, not only based on the pass length, potentially also policy. So you see, these BGP advertisements, therefore, carry not just the AS pass, but also some additional information. And we call these all the attributes, route attributes. Okay, so in the next video, you will hear Polly giving you a few examples of how these attributes might look like. And you will hear for the first time officially how AS routers, before they apply the computation, making decision, okay, they need to decide whether to import certain AS pass. So an AS router, the gateway routers, could receive multiple AS pass information to a particular destination. And the gateway router will need to decide whether we import all of them or some of them. Similarly, after the route decisions are made, the gateway routers will also decide whether we propagate some of the pass vectors, some of the AS pass discovered further. All of them, or a subset of them, or a particular subset to a particular AS, another subset to another particular AS. All right. So it sounds already complicated. It is a little bit complicated in BGP. The routing is.
Let's say more about the messages we exchanged in these BGP sessions. So these messages are essentially pass vectors. Inside the pass vector, we have lots of these pass entries, okay, or route entries. Each pass in the pass vector of BGP is this: the destination address. Now, because in BGP we are sending packets to a destination network, therefore, to address to a destination network, we use the prefix of the destination network. And then attributes. Now, in pass vector, the most important information there is the path. Therefore, you see, okay, in the set of attribute here, we need to definitely have the AS pass. So AS pass is the most important component in the set of attributes. There we see the list of ASs, okay, it takes from the source to reach the destination. Now, the discovery of the list of ASs, the discovery of the AS pass, however, okay, came the other way, from the destination network. Okay, so the destination network is going to advertise its prefix, okay, and so that's going to be in an advertisement message. Okay, so the home AS of the network X, okay, let's say AS2, okay, receiving such an advertisement at the gateway router, okay, that gateway router is going to prepend itself, okay, prepend the AS number, okay, AS number 3, okay, before X, and send this out as the prefix advertisement to the neighboring AS. The neighboring AS, let's say AS2 there, receiving such, okay, an advertisement, it's going to prepend itself before it sends out further to AS2's neighboring AS. Okay. So now AS2's neighboring AS receiving such an advertisement will then discover, right, a path to go from AS2, AS3 to destination X. Okay. So list of ASs through, okay, these paths, the prefix advertisements has traversed. Okay. So that is the AS path. One and the most important, okay, part in the attribute set. Second important is this, the next hop. Now this is not quite, okay, the next hop AS, the next AS number, okay, in the AS path. No. It is actually the gateway router, okay, within the source AS that is directly connected to the next hop AS. So it's carrying the IP address, okay, of the gateway router, leading to the next hop AS. So the two together necessary forming the attribute set. Now, BGP routing, okay, has grown more and more being policy based, okay, meaning the gateway router, they're receiving these prefix advertisements. Okay, it's not like for every advertisement they will actually prepend its own AS and then pass it down further to other neighboring ASs. There'll be some sort of import policy. Okay, so the gateway there receiving the advertisements will have to say, okay, will have to decide. Some of the advertisements they will decline, and some others they accept. Only the ones they accept will be propagated further to all the routers within the AS. Now the gateway routers, okay, in the AS receiving these accepted, okay, advertisements will then decide whether to prepend themselves and then pass the expanded advertisements, okay, to the other neighboring ASs. Okay. But you see there are also policy, okay, the AS might apply before these other gateway routers, okay, advertise the expanded, okay, AS path to the neighboring ASs. Okay, so some of them actually might have complex policy that is very fine-grained. For example, if one gateway router, okay, connects to two other neighboring ASs, this gateway router might say, I send this particular extended advertisements only to one of the ASs. Yeah. Policy to import and policy also to export.
All right, so you see, policies not only used, or attributes not only used in determining routes, but also at the time to determine importing policy, importing routes, and exporting routes. Okay, so for now, it might not be very clear why you want to set up policies importing routes and set up policies exporting routes. What I can give as a hint is this. Internet, as I mentioned, it's a global infrastructure. Everyone needs it, but it's also a business. So an AS can use the import policy to try to exclude traffic going through a particular domain or going through a particular area of the world. And the export policy, okay, will also decide or influence partially how the traffic is going to come through our domain. Okay, and so if you don't want a specific area of the world to pass data through us, or if you want to attract certain area traffic to come through us, then you can play some tricks at the export policy. All right, so BGP very policy based. All right. And you know what, guys? I begin to see you guys responding to the pop-up poll. So let's see. Do you like BGP sessions being TCP? Henderson says no. Okay. Henderson says instead of BGP, instead of TCP, let's use the secure TCP, the TLS. That will make the exchange of these reachability informations or the path vectors more secure, because routes, in case there's some bugs, then the data will just running around, sometimes going a loop, okay, on the internet, and that's probably much worse than just having individual packet loss. So good point there, Henderson. And Paul here says no, right? But let's see. Paul doesn't like BGP using TCP because it feels like it's heavy. For TCP, one needs to do a three-way handshake to establish a session, isn't it? And after you send the advertisements, you take it off. And another advertisement comes, you set it up. Right? That's a lot of control overhead just to send individual advertisements. Good point. In terms of performance, right? Efficiency, TCP seems expensive. Let's see. Caesar says yes. It leverages TCP's reliability and flow control. Yeah, so hey, TCP does reliable transfer, right? And there's also flow control in case the internet is busy, right? Sending of these advertisements will also need to adapt itself, okay, to the internet traffic. All right. And let's see, Luis. Yes, sending it through TCP is reliable. And there's also congestion and flow control. Yeah, the message will arrive intact. That's good. And let's see, James, using BGP makes sense because it ensures reliable delivery, right? And this is definitely compared to send a native IP message. I guess James and Luis and Caesar are thinking that sending over TCP, which is reliable, versus sending through UDP or native IP. Native IP, of course, there's no data recovery, right? So at least what you guys can achieve is that the route advertisements will reach the other end, which is adds robustness to BGP. So I guess Calvin goes the similar direction. Yeah, it will be reliable and messages will arrive in order. That sounds like a good feature for such an important decision one needs to make on the internet, isn't it? Yeah, Devin says yes, BGP, because it's important. Regarding security, we can integrate both. Okay, Devin, nice, because yeah, of course you can run it on TCP. And how about running a secure version of TCP? But by the way, TLS is implemented at the application layer, all right? So essentially, guys, you are not all objective to, except I think Paul, right? Saying that it's expensive. I totally agree. But most of you say that, hey, it's probably okay, right? Let's do it, do a transport layer that's use a transport layer protocol to send a network layer protocol's message. Yeah. Suppose the network layer does not see the transport layer headers. Okay. Okay, so Pingyu was saying yes, ensures reliability. But by the way, if we send BGP over TLS, then it will be sending network layer messages over an application layer protocol, right? The header goes all the way up to the application layer. Guys, you hear that it's a little bit tricky, isn't it? How does network layer send such a thing? So it's kind of violating, again, the layering principle, isn't it? Okay, Bingwei also says yes, and you guys are going for the reliability of TCP. I totally agree. PG sending through TCP because it's important message and it's better delivered reliably and quickly. TLS, it depends on the version of TLS, by the way. Henderson, TLS 1.2, there's probably 5-way handshake before the real data can go. Yeah, so going through TLS, it would certainly be slower than TCP. But good thing is that TLC 1.3 is only 3-way. Okay, so yeah, you see that extra security, extra reliability usually means slower connection. Okay. Yes, ensures reliability and also does congestion control compared to UDP. Louis is curious now. When YouTube blocks a video in a country, would it prefer using import policy or export policy? Very good question. Very good question. Sometimes, from me, I would say export policies is going to be very effective if they just not announce themselves. But you see that blocking specific applications traffic at the network level is also a little bit risky, Luis. You see that these routing informations are used by all applications. So yeah, if we set some export policy and block traffic coming from certain region to enter, that is also saying that all the application traffic coming from that region will also be blocked. So if I am not mistaken, from what I know, the practice is more that if you want to block a specific traffic, specific application, that is usually associated with a specific set of servers. What people do at the country level is to manipulate the DNS entries. Yeah. And you see that DNS is also somewhat a network level information. That is for you guys, for us to get the IP address from a service's name, right? From a server of the service's name. Okay, Luis, I hope that I answer your question. And let's see, Josephine? No, because BGP relies on TCP session. If the session drops, yeah, because reassessments will take also time. Yeah, good, agree. Yeah, so Josephine, very good. You and Paul dare to take an opposite position, the not so popular position. Why a lot of censor app in other countries just indefinitely charges sometimes? Charges sometimes. So Louisa, I'm actually not quite sure what you meant by charges. Okay. Yeah, elaborate when you find time, all right? And we can come back to this. I see that you have, you now get curious about these import-export policies and how you can manipulate traffic, okay? Indefinitely. That could be the reason. So DNS entries manipulations or round manipulations, they could create this, indefinite no, this notion of, hey, not sure where to go. So if you do this over a web browser, what you might get is a destination not found, something like that. All right. And hey guys, good to get you guys get interested in BGP. Now, last video, we're still in the overview, okay, is to give you 2 examples so you get a better sense of how BGP works, okay, visually. First example is straightforward because there's only one AS path. Okay, so one domain sends reachability information to the next domain. The next domain adds its own AS number to that reachability information and go on. And therefore you see reachability information or, hey, I exist. The existence information gradually becomes the AS path. The second example then gets complicated. You have 2 routes to a particular destination, and you will see the potential source there needs to make decisions.
Let's go over a couple more examples so it's more clear where the import policy and the export policies are applied. So this is the same example we saw earlier. Destination network is here, X, okay? And so AS3 there is gonna send the past advertisement. Okay, that looks like this, AS3, comma, X. Okay? And this is gonna reach 2C of AS2. So AS2's router 2C receives past advertisements like this. And this is through the exterior BGP connection. And the advertisement came from AS3 and from router 3A. So 3A of AS3. Now, if you recall in the very early slide, right, the border router here will then propagate the AS path throughout all routers in the network. But no, there's import policy. So the exact process is more like this. 2C there will actually check AS2's import policy. If the policy says 2C, it's okay to accept the path, then 2C propagates the path to all routers internal of AS2. Okay. So sending of these AS paths internally is through the interior BGP connections. All right. So the import policy actually happens before the propagation of the path, okay, to all the routers internally. And then 2A here, receiving such a path, can then prepend itself and pass it further to the neighboring ASs. But wait, the export policy is applied here before passing on of the advertisements. Let's check. If 2A here is allowed to advertise the discovered path to AS1 here, okay, then we form the new advertisement AS2, AS3, and X, and then send it to 1C that belongs to AS1. Okay, so once again, before the prepended, the extended AS path can be advertised further to the rest of the internet, we check the export policy. Right? Second example is a bit more realistic. So 3A here, the gateway router of AS3, might have multiple eBGP connections to outside. Okay, so in that case, a gateway router might learn multiple paths to a destination in AS3. So let's see. One of the paths is this, right? AS3's 3A sends AS3X, okay, as an advertisement to 2C. 2C checks the import policy and therefore pass it on to all the routers internally. 2A picks it up, checks the export policy, and let's say that it's just allowing advertisements of the path further. So prepend AS2 to the path and then send it further. At this point, 1C learns the path AS2, AS3 to destination X. And the way to go is for 1C to send to 2A. The other direction is this. 3A can be simply sending what? AS3X, okay, this past advertisements directly to 1C. And 1C will just simply learn, right? There's another way to reach destination X, which is just simply sending it to AS3 through 3A. Okay, so these are the gateway border routers that 1C send the packets to, okay, for the 2 different paths, okay, 2A and 3A. At this point, 1C sees 2 advertisements coming in. Before 1C propagates any of the paths further, okay, it needs to check the import policy. Okay, so AS1's gateway router 1C there, okay, we need to choose. It could choose one of the two, or it could just take both of them. Okay, let's say that 1C chooses AS3, comma X, yeah, sure, the shortest AS pass, and advertise it to all routers internally of AS1. Okay, this is the second example.
All right, good. So guys, you can probably imagine, for example, Ukraine will probably not take the AS pass imported from Russia, right? Because that way, Ukraine might be sending a bunch of traffics to Russia and giving Russia some opportunities to eavesdrop. So you see, things can be a little bit complicated for the international routing, okay, as well. So it's not just a shorter distance being one of the consideration. Internet is a business being one of the considerations, but also regional differences, okay. Regional differences. Let me put it in the softest way, the least sensitive way. All right. Oh, and I see Ricky finally dropping in. I prefer BGP. It seems preventing network overload with large routing tables. Then speed. Okay. So I think you do prefer BGP sending advertisements through TCP, right? Good. Yeah, good that you try to be brief because we are running out of time. All right. Now let's get into the BGP details. Okay, and unfortunately, we'll need to do quiz 49 along with quiz 50 to 53 tomorrow. And chances high that we might not be able to cover much of chapter 6, all right, this semester. And so first, internet routing, BGP is at the inter-AS level, okay? How does a intra-AS router know where to send the data for a destination outside of the AS if the intra-AS routers does not see these AS paths? But then when these AS paths arrive at the intra-AS router, how would that change the forwarding table? Okay, we see an example earlier, but that was very, very high level. Now you will see, borrowing the example 2, we'll see how that forwarding table within a router inside an AS is constructed so that data can go out to destination outside of the AS.
Let me borrow example 2 here and continue to talk about this. How a router sets up a forwarding table entry, okay, for a destination outside of the AS. Scenario of the same, destination being X. 3A, the gateway router of AS3 has 2 eBGP connection, therefore 1C here potentially can receive 2 AS paths. And 1C, according to example 2, chooses the shorter AS paths. So let me run the animation. So 1C discovers 2 paths and picks the shorter paths. Okay, and this shorter path is further propagated internally to all routers. So 1A, 1B, and 1D will learn about the shortest path to destination X from 1C. Okay. And what 1A, 1B, and 1D will do is, well, if I receive ever any packets with destination X, then I will forward the packet towards 1C, the border router, okay, they receive, okay, the AS path from. Okay. Now, to make it easier to explain what's coming up next, let me just label, okay, for 1A, if the packet is supposed to go out on this interface, then we call that interface 1. And yeah, for packets to go out on this other interface, let's call it 2. Okay, similarly for 1D, this is interface 1, this is interface 2. Now, 1D here, okay, has discovered there is a path to destination X that is going through 1C. Okay, that is what 1D knows so far. To add an entry into the forwarding table for X, 1D needs to know exactly which interface, is it 1 or 2, that leads to 1C. How would 1D know that? Yeah, call the intra-AS routing there. Okay, let's say it's OSPF. Okay, so OSPF is going to tell us if the destination is 1C, what is the link, okay, along the shortest path to 1C. Okay, so that happens to be 1, so we will fill this entry here, okay, interface column being 1. Similarly, let's try to derive again for 1A. Okay, so 1A knows, for destination X, I should be forwarding packet towards router 1C. So let's call intra-A's routing and find out from OSPF. What is the shortest path to 1C? And which link, is it 1 or 2 on the shortest path? And we'll get 2 here, and 2 here would forward packets to 1D, and 1D here we see earlier will be forwarding packets over this direction and reaching 1C. Therefore, going backwards and reaching destination X.
All right, so now you see it's not that hard. It's essentially that a router inside an AS just needs to know that for the particular destination, which is the gateway router to get the message out. And then call the intra-AS routing to find the interface going to the gateway router. All right. But you know what, guys? That video there we played is the simple case because there's only one gateway router holding the AS path to the destination network. The next video is a complex case where for the internal routers, there are potentially 2 gateway routers. Each of them holds AS paths to the destination network. Okay, in that case, that router in the middle of the AS would use hot potato routing. Okay, and that is something that we will talk about tomorrow, the first thing tomorrow. And quiz 49 will follow immediately after that video. And with that said, I say the time is up, 2:11 already. So I say goodbye now, and guys, I see you tomorrow 10:20 so we can talk about hot potato routing. All right, see you tomorrow. Okay, bye. All right, bye. Yeah, so there are 5 quizzes, potentially 6. So maybe we won't be able to do quiz 54 either. Okay, bye. Yeah, so BGP is a complex subject. Sorry that I felt that maybe we do a more careful setup first before introducing you guys to BGP. All right. Okay, bye. Oh, Louise. But you know what? Hey, summer is ahead. Vacation. Not bad either. Yeah, but good to know that you guys want to learn more. Yeah, if you stay in Taiwan, yes, it is gonna be intense heat. Okay, drink a lot of water. All right.